if you're in my class, this question numbers will match the review of Test 1 for College Algebra, Math 13-14. If not, I hope you can grab what you need from the videos. So on number 4, we are looking at determining if the relation is a function and state the domain and range, and why or why not is it a function. So the first thing we're going to do is find the domain. Remember, the domain is the values of x and the range is the values of y. So our x values are going to be -6, -3, 4, and we see that our 4 value repeats. We don't write it the second time. Now, the range is going to be our y values. So we've got -5, -7, 6, and 8. When we determine whether or not it's a function, we look to see if the x values repeat. And in this case, our x values do repeat. So no, this is not a function. And the reason is the x value repeats. That means our domain repeats. So if we put in a 4, we're either going to get a 6 or an 8. Therefore, we don't know which one we will get, so it's not a function. The next question we're going to look at is number 6. Find the domain of the function and write in interval notation. So we're looking at finding the domain of this function. We're looking at what happens to the denominator. Remember, we can't divide by 0. So that's what we're concerned at in this problem. There's another thing we need to worry about, and we'll cover that in the next problem. So in this case, what we're going to do is set our denominator equal to 0. That will help us determine what causes us to get 0 when we divide, and we can remove that. So we're going to add 36 to both sides, opposite of what's being done. We have x squared is equal to 36. Now we're going to solve this by taking the square root of both sides, which gets us x equal to the square root of 36. So that, remember, it's whenever we introduce the radical, it will be plus or minus. So plus or minus the square root of 36. So x will equal plus or minus 6. These are the values that will cause us to divide by 0. Another way you could have solved this is you could have set it equal to 0, and you can see that this is the difference of squares, and you could factor it. Either way is a correct way to go. Remember, with difference of squares, it's the same thing with the plus or minus. So x plus 6 and x minus 6 is equal to 0. Now you will set each part equal to 0 to solve. So we're going to subtract our 6 on this side. So x will equal -6. Add our 6 to this side, x equals positive 6. If you notice, we get the same answer either way we solve the denominator equal to 0. The next part said we had to write in interval notation. So to write in interval notation, we're going to draw a number line with -infinity and infinity, and we're going to put the two numbers that we're concerned about, -6 and 6. So we can, these answers mean that we can't have x equal to -6 or 6, because if we plug those into our denominator, they will equal 0. 6 squared is 36, minus 36 would be 0, and -6 squared will get us positive 36, and minus 36 would get us to 0. So after we draw our number line, we're including every number except those two, because they will cause us to divide by 0. Now we just bring down the numbers that we have in interval notation. And you have to remember to put the unions in between each of them. This tells us that every number except -6 and 6 are fine to be in our domain, because every other number will not cause us to divide by 0. The second type of equation or exception for our domain would be that we can't take the square root of a negative number. So in this case, because we have the square root in the bottom in our denominator, we're going to take that denominator, and what's inside of it we are going to pull out. So we'll have x minus 10, and it's going to be greater than 0. We can't set it equal to in this case, because if we set it equal to 0, then we'll end up with 0 in the denominator. So in this case, we're actually going to just let it be greater than 0. So any other value will be fine. As long as we end up greater than 0, we'll be fine as far as can't divide by 0, and we can't take the square root of a negative number. Now if this was not in the denominator and it was in the numerator and we didn't have something on the bottom, then we would just have it greater than or equal to 0, because we're allowed to take the square root of 0. So now we're just going to solve it. So we're going to add the 10 to both sides, and this will get us x is greater than 10. And we can see that if we plug in 10, we would get 10 minus 10 is 0. This is not okay for there, but if we plug in 11, we'll get something greater than 0. It will not be a whole number, but it'll still be greater than 0 and we'll be fine. Now to put this in the interval notation, we're going to draw our number line again. So again, we've got negative infinity to infinity, and we've got our number 10. Now you can put as many numbers on your number line as you want. I choose to only put the ones I need so I don't clutter it up and I can keep track. Whenever it's greater than, we're going to go to the right. Because it does not have a line for the equal than, we are going to put, or equal to, we're going to put the parenthesis there. So we'll bring it straight down, and this will get us parenthesis 10 to infinity parenthesis. That would be our domain for this equation here. Now, the next question that we're going to look at from our review is question number 21. This is where we're determining the domain and range of the graph. What are the x and y intercepts? Is it a function? Why or why not? Well, if we're looking at the domain of this, remember the domain is the x values. So if we're looking at the domain, we're looking at our x values along the x number line, and we can see that we start at 0. So we're going to go from 0, and we can see that our graph continues on, so it'll go on to positive infinity. So that will be our range. Now, our domain. Now if we notice, we actually include the 0, so this one will have to be a bracket. Not just a parenthesis, but a bracket. And remember, infinities only get parentheses. Now if we're looking at our range, this will be our y values. We start from down here at the bottom and we work our way up, and we see that we hit number 2. And it includes number 2. It's got a solid circle there. So we're going to start at 2, and as we continue up, we can see that the line continues, so it will also go to positive infinity. Now the x-intercepts, we're looking at where does the graph touch the x-axis, and we can see that it doesn't go anywhere near the x-axis, so here we're going to write none. Make sure on the test that you would actually put none, so it doesn't look like you just skipped that part. On the y-axis, we're looking at this here. We can see that it intercepts right at the 2. So our y-intercept is going to be 0, 2. Remember, you always write an intercept as a point, because that's where it's intercepting, and it's 0, 2. Now, it says determine if it's a function. Is this a function? Well, we can draw a vertical line and see that it is a function because we would only hit one time. So if we draw our vertical line going down, we can see that we're only hit it at one time. So yes, it is a function, and the y is going to be the vertical line test. So this should cover the parts of the review that deal with determining the domain and the range.